Okay, so good day guys. Our topic for today is all about the mole and mass relationship. So in our previous discussion, now we discussed about the molar mass and the conversion of the mole. What is the relationship between the mole and the representative particles? So we're in representative particles can exist as atom, as a molecule, as an ion, or as a formula unit. Okay, so it depends on the compound or the element that is given. Okay, so for this day, we will talk about the mole and the mass relationship, and then um, uh, we will also connect. Okay, so the previous lesson which is all about the grams per mole or yung molar mass nga po natin. Okay? So, yung mole and mass relationship natin is somehow related to the conversion of the mole and also the molar mass. Okay? It is because gagamitin natin yung dalawang topic na yon to distinguish the relationship between the mole and the mass. Okay? So, let's have an example. Okay, so we have here um, we have the molar mass. Okay, so the molar mass of a lithium. Okay, so we have grams per mole of lithium. Okay, so we all know that a lithium has an AMU of 6.94. Okay, so that is the AMU of the lithium. Okay, so if we will round off that into whole number, we will get 7. So we have the molar mass of a lithium atom is a 7 grams per mole. Okay, so now what is the difference between the mass in grams and yung molar mass? Okay, so ibig sabihin lang muna nito, unahin ko lang yung molar mass. So ibig sabihin po nito, for every 1 mole, okay, so there is an equivalent. Okay, so there is an equivalent approximate value of 7 grams. Okay, so for every 1 mole, there is an equivalent value of 7 grams ng lithium. Okay, so halimbawa naman, kung NH3 yon, okay, so halimbawa we have NH3, which is ammonia. Okay, so we have, ang molar mass ng ammonia is 17.03. Okay, so magiging 17 na lang siya. Okay, so we have 17 grams per mole ng ammonia. Okay, so ibig sabihin yan, for every 1 mole, there is an approximate value of 17 grams ng ammonia. Okay? So you have there, para may convert natin yan, di ba, gumagamit tayo. For example, kukuhanin natin yung atoms nito, no? Gumagamit tayo ng Avogadro's number, which is 6.02 times 10 raised to 23rd. And then, since this one is a lithium, so atoms yung gagamitin nating representative particle. And then, if we were talking about the NH3, no, since this one is a covalent compound, so the representative particle is a molecule. Okay? So, this one is ito yung mga ginagamit natin. Okay? Na conversion factor, 'di ba? Doon sa previous lesson natin. Okay? So gawin natin yung relationship between the mole and the mass. Okay, so we have to calculate the letter A, the mass in grams of 1.25 moles of lithium, and letter B is the number of mole of the NH3 in a 345 gram of sample of gas. Okay, so yung sample of gas natin dito is ito na yon yung NH3 natin. Since ang NH3 natin is ammonia, okay, so which is an example or an example of a gas, okay, so of a matter gas. Okay, so first step natin is to unahin muna po natin yung letter A. So magkaiba po to ha, hindi yan magkasama. Okay, so dun muna tayo sa letter A. So we will calculate the mass in grams. Okay, given the 1.25 moles of lithium. Okay, so first step is to determine the relationship of the mole and the mass. Okay, so that's why kailangan po natin ng molar mass. Okay, so I told you earlier that a lithium has a molar mass of 7 grams per mole. Okay, so meaning to say for every 1 mole, there is an equivalent approximate value of 7 grams. Okay, so para makuha po natin yung mass in grams given the 1.25 moles, i-convert lang po natin yan. Okay, so paano? So let's start with this formula. So we have the find, which is the grams of lithium. Okay, grams of lithium is equals to the given 1.25 mole. Okay, so you have there 1.25 moles of lithium and then multiplied natin siya sa molar mass. Okay, so nakalagay dito for every 1 mole there is an equivalent 7 grams. Okay, so meaning to say if we will find the mass in grams, therefore ito yung i-remain natin na unit. So we will start at 7 grams over the 1 mole. Okay, so you have there the relationship 1 mole is equivalent to 7 grams. So 1 mole is equivalent to 7 grams. Okay, next is cancel natin yung moles niya and you will get 1.25 multiplied by 7. That's equivalent to 8.75 grams of lithium. Okay, so this one is the mass in grams of the lithium. Okay, so that's how you get the mass in grams using the given moles. Right? So next one is the number of moles. Okay, so how about the number of moles or yung letter B naman natin? Okay, so number of moles. Okay, so number of moles of ammonia. Okay, so balikan lang din natin yung kanina, no? Yung grams per mole or yung molar mass, the molar mass of the ammonia. Okay, so ammonia has a molar mass of 17. Okay, so we have 17 grams per mole. Right? Okay. So meaning to say, for every 1 mole, there is an approximate value of 17 grams. Okay, so given the mass, we need to find the moles of the NH3. Okay, so wag malilito dun sa dalawa ha, kasi 'di ba, ang molar mass natin is in grams per mole. Okay, so ibig sabihin hindi pa to yung sinasabi nating mass talaga. Kasi meron pa siyang kasamang mole. Okay, and then hindi rin to yung mole kasi meron pa siyang kasamang grams. Kaya natin pinaghihiwalay yung grams dun sa mole pag kinukuha natin is yung mass. Kasi pag sinabi po nating mass, we were talking about only the grams. And if we are looking for the mole, or the amount of substance, we are looking only for the amount of substance, which is the mole. Okay, not including the grams. So that's why kino-compute natin to. Alright? So given the grams, okay, so ang kukompute natin is the mole of ammonia, which is equals to the given 345 grams of NH3. Okay, and then multiplied natin since the mass yung ika-cancel natin na unit, so nasa ilalim yung mass niya. So you have there the 17 grams and then the 17 grams is equivalent to 1 mole. Okay? Next is to divide this one or multiply it by 1 and then divide it by 17. So you have there 745 grams multiplied by 1 and then divided by 17, the answer is 20.29. Okay, so cancel natin yung unit na grams and then you have there the mole of NH3. Okay, so that's how you get the mole, okay, given the grams of a sample or grams of a compound. Okay, so generally we have these equations. Okay, so to convert the mass to mole, so the general equation is the mole. So we have the moles is equals to the mass in grams multiplied by the grams per mole. Okay. So, ito yung mass na given natin kanina, nasa ilalim, since ang ika-cancel natin na given is yung mass. Okay? And then, nasa taas po yung mole. Okay, to remain the unit of the mole. Okay, so next one, to convert the moles to mass, the general equation is the mass in grams is equal to the number of moles multiplied by the mass in grams over the 1 mole. Okay, so baliktad lang yung process. Okay, so wag po malilito. Etong part na to is the molar mass of the compound or the element. Okay, so ito yung mga part na yan. And then this part, okay, is the given. Okay? Okay. Okay, so before we proceed to the next lesson, so I want you to try this one. So for number 1, find the mass of 7.25 moles of aluminum oxide. So we all know that aluminum oxide has a chemical formula of Al2O3. Okay, so that's aluminum oxide. And for number 2, how many moles of iron 3 oxide are contained in 85.5 grams of pure iron 3 oxide? Okay, so for this problem, the question is how many atoms of gold or Au are there in a pure gold nugget having a mass of 34 grams. Okay, so we have there the given of the mass, which is in 34 grams. The next one is to get the molar mass of the gold. So we have there the molar mass. Okay, so the molar mass of a gold in the periodic table, a gold has a 197 AMU. Okay, so we have 197 AMU. Okay, so we have 197 AMU. Therefore, this one is it is the grams per mole or the molar mass of the gold, since the gold is an element. Okay. So you have there the grams per mole of AMU. Okay. So next is we need to find the number of atoms. Okay, so we have there the number of atoms. Okay. So using the formula, we need to convert this first. Okay, so we need to convert this first into mole and then tsaka po natin siya i-convert into atoms. Okay, so let's have the shorthand. So you have there the moles. We need to get the moles of Au. Okay, go. So given po kasi ang grams niya, kaya ang hahanapin po natin is the mole. Okay, so given the moles, so find the moles of Au is equals to the mass of the Au and then multiplied by the molar mass, 1 mole Au over the number of grams of Au. Okay, so substitute, we have the mass of Au, which is 34, multiplied by 1 mole over the 197 grams. Okay, so next is to cancel the unit gram, and then we have 34 times 1 divided by 197, and that's equivalent to 0.17 mole. Okay, so we have there the 1.7 mole of 0.17 mole of AU. Okay, so next one is to convert this one. You already got the moles of AU, and then you are able to get the number of atoms. Okay, so by using the Avogadro's number. Okay, so let's just move this one. All right. So if we will review the last topic, the Avogadro's number is equals to the 6.02. We have there 6.02 times 10 raised to 23rd. Okay, so that's the Avogadro's number. Given the number of mole, right? So we will convert it into number of atoms using the Avogadro's number. Okay, so we have there the find, which is the atoms of AU, which is equals to the moles of AU multiplied by the Avogadro's number. Okay, so you have there 6.02 times 10 raised to 23rd, and then write the atoms of AU over the 1 mole. Okay, so why 1 mole? It is because 1 mole is equivalent to 6.02 times 10 raised to 23rd. Right? So next one is to substitute. So we have there the moles of AU. We have there 0.17 moles of AU multiplied by 6.02 atoms of AU over 1 mole. Okay, so next is to solve this one, we have 0.17 multiplied by 6.02 raised to 23rd, and then the answer is 1.02 times 10 raised to 23rd atoms of AU. Okay, so you have there the atoms because the unit of mole will be cancelled during the calculations. So that's how you solve the number of atoms or the number of representative particles if the given is in mass. Okay, so the first thing that you should do is to get the number or the given, and then if the given is mass, convert the mass into mole, and if the given is mole, convert the mole into mass, and then proceed to the calculation of the number of atom using the 6.02 times 10 raised to 23rd. Okay. Okay, so before we proceed, let's try this sample. Okay, so I want you to try this one. How many representative particles are in each of the following samples? So for letter A, we have there the 11.3 grams of lead. And then for letter B, we have 44.2 grams of Mg or magnesium. And then for letter C, 0.582 kilograms of silicon dioxide. So as you can see, you have there the kilograms. So we need to convert this one into grams. And then you have to get the molar mass of each of these elements and compounds. Okay, so we have here a sample problem. Helium is it's an unreactive noble gas that is used to inflate balloons. A party balloon contains 3.33 times 10 raised to 22nd or 22 atoms of helium gas. Find the mass in grams of helium. Okay, so we have there the given, the number of atoms. Number of atoms is equals to 3.33 times 10 raised to 22. Okay, so you have their atoms of He or helium. The next is we need to get the molar mass of the helium. Okay, so we have the molar mass of the helium is equals to 4. Okay, so we have there the AMU. The AMU of the helium is 4.003. So we have there the 4. Okay, so 4 grams per mole of helium. Next is we need to find the mass in grams. Okay, so find the mass in grams. So the first thing that we should do or that we must do is to convert first the number of atoms into moles. Okay, so parang katulad lang din to nung kanina pero pabaliktad yung process. So nung una, yung mass in grams yung given pero ginawa natin siyang mole and then yung mole ginawa nating number of representative particles. Okay, so this time we will do the reverse. Okay, reverse process. So first, we need to get the number of moles using the number of atoms. Okay, so paano natin gagawin yon? So we have there the 3.33 times 10 raised to 22. This one is the number of atoms, and then we will convert that into number of moles by multiplying it into number of mole. Okay, so we all know that for every 1 mole, there is an equivalent 6.02 times 10 raised to 23rd representative particles. Okay, so since our representative particle is an atom, so we will use the atom. Okay, next is, kung ano man yung lumabas dito, okay, pwede na natin siyang gawin na mass in grams. Right? So we have there, cancel natin to. We have to cancel the atoms. So, the answer is C 0.055 or pwede din naman na 0.06. Okay, so that's the moles. Okay, so moles of He. Okay, so next is this He. Okay, so this mole ay i-convert natin into grams. Okay, so we have there the given gamitin natin yung 0.055. Okay, and then mole of He multiplied by the grams per mole. Okay, so you have there the grams per mole. So lagay natin sa taas yung 4 grams and 1 mole sa baba to cancel the unit of mole. So cancel. So you have 0.055 multiplied by 4 is equals to 0.22 grams of He. Okay, so that's how you calculate the number of grams or the mass in grams of an element or a compound if the given is in representative particle, just like this one. Alright? So, sa nakikita nyo, dalawa yung equation na ginamit ko. Pero, pwede nyo siyang gamitin as dire-diretso na. Okay? So, ano yung ibig kong sabihin? So, pwede nyo ang gawin is to, after you write this equation, no, pwede nyo idugsong yung you have there 4 grams, lagyan nyo yung 4 grams dyan, and then you have there 1 mole. Okay, so cancel yung mole. And then, pwede nyo na kayong magdiretso ng ganitong equation. So, let's try to answer this one. So, you have there 3.33 times 10 raised to 22 divided by 6.02 times 10 raised to 23rd, and then multiplied by 4, and the answer is 0.22. Okay, still, you have the same answer. It's up to you kung ano yung gagamitin yung equation. If you want this one na isang diretso lang, better din naman para hindi na masyadong maraming sinusulat. Alright? So, same answer paran. So, you have there 0.22 grams of helium. Okay, so we have this. Let's try this sample problem. So, I want you to calculate the mass in grams of each of the following samples. Number 1, 1.50 times 10 raised to 18 atoms of neon. Number 2 is 8.35 times 10 raised to 21 molecules of CH4. And number 3, 6.02 times 10 raised to 25 formula unit of zinc chloride. Okay,